All right, so I'm going to share my whiteboard, right? You all see my whiteboard?
Yes, sir.
All right, good. So today we're going to review some like algebra stuff that you really know. Now, remember what Miss Dalmont said, when you get to calculus, fellas, you know, about 80 to 90% of what you do in calculus is actually algebra. So one of the most important tools that we're going to have to remember is this idea of factoring. All righty. Hold on. Every once in a while, fellas, I might actually have to check my phone. My aunt in Ireland had a stroke this morning, and she's in the hospital. She's not in good shape. So if I stop talking for a few seconds, that's all I'm doing. All right, so what we're going to do, all right, so we're going to learn, we're just going to go over our rules for factoring. Some of them are going to be really easy, and because it's really not that hard to do, and you're all pretty bright. So we're going to be talking about specifically using the greatest common factor, the difference of two squares, right? Quadratic trinomials, and then what we call, right? And then what we call factoring completely. And when we say completely, that just means that we're going to do multiple steps. So we're going to say, oh, we should factor this polynomial using this style. And then after you do that style, you realize that one of the factors can also be factored using a different style. So let's remember what it means. So if I said to you, 10 is the number. One of its factors is 5. What's the other one?
2.
Well, it's 2. Why? Because 5 times 2 is 10. So when we say to factor something, what that means is to break it down into two numbers whose product is the original. The difference is, what we're going to do here is we're not using numbers, we're going to be using polynomials, all right? So the hardest part, or the most important part, is to be able to look at the polynomial and determine what method of factoring should be used. Now, what we're going to go over is not the only methods of factoring, but are the most often used, okay? Because now we're just reviewing some algebra so that we're ready to do the algebra we need to do right out of the gate with calculus. Does that make sense?
Yes, sir.
Right? So when you find this to be really, really easy, the reason you're going to find it to be really, really easy is because for you guys, it probably is, okay? So first one, using the greatest common factor. Now, anytime we're asked to factor, we figure out which method. Sometimes we can look at the polynomial right away and know exactly what it is, but sometimes we can't. So what we want to do is always look to see if we should factor out the greatest common factor. So, for example, all right, if you're going to use the GCF, there's just simply two steps. Find the GCF. That's your first factor. All righty? And then the way you get the second factor is you divide the polynomial by the GCF. And that gives you your second factor. Okay? So for example, if I said to you, you have the number 10, and I said to you, one of the factors is 5. What's the other one? Well, you would just do 10 divided by 5 and get 2. Well, we're going to do the same thing, only instead of having a number, we're going to use polynomials. So, for example, 3x squared minus 6x. So for you guys that really didn't learn your rules for factoring, this is going to be a good good review for you, all right? Because we're going to go over the most important things you have to know, right? So I know that I have a polynomial, and this polynomial is called a binomial because it has two terms. When I say, ooh, it might be the difference of two squares because I see a minus sign. But we look at it really quickly, and we know that that's not the difference of two squares because 3x squared and 6x are not squares. They're not perfect squares. So I sit there and I go, I wonder, is there a greatest common factor? So one way you can do that, well, I know that the greatest common factor is 3x, and you also 2, right? But you might be able to sit there and say, well, I don't know what the greatest common factor is, or there's a lot of terms, so I want to make sure I don't make a mistake. So one way you can do it is you can look at the numbers, the coefficients, 3 and 6. What's the biggest number that goes into both of those? 3, obviously. And then you can look at the variable x, and one term has an x squared and the other one has an x. So you always take the lowest exponent because x goes into x squared. X squared doesn't go into x. So now I have my GCF. There's my first factor. And then all I got to do is divide the polynomial by the GCF. And when you divide a polynomial by a monomial, when you divide a polynomial by a monomial, you simply take the monomial and put it into each term. So 3x squared divided by 3x gives me x, and 3x into negative 6x gives me minus 2. And that should be factored properly. And we can always check it. How? How? Yeah, just do the multiplication. And you should end up with what you started with. That's not brain surgery, right? That's not brain surgery, right? Oh. All righty. Let's do another example. We're just going to add another term, and we're going to add another variable. So we're going to start with 8, x to the 4th y squared plus 6, x to the 3rd y to the 3rd minus 2, xy to the 4th. Now, if I say to you, factor this, I'm asking you to break it down into two things you multiply together. Well, it's certainly not a quadratic trinomial, and it's not the differences. I'm going to use the GC. I'm going to look to see if I have a greatest common factor between each of these terms, all right? Now, you might already know that it's 2xy squared, but you might not already know that. So one thing you can do is look at 8, 6, and 2. What goes into all of those? 2. I look at x to the 4th, x to the 3rd, and x. That would be x. And then I simply go y squared, y to the 3rd, y to the 4th. That's y squared. So there's your GCF, right? Now, I'm simply going to take that GCF and divide the polynomial by that. And when you divide a polynomial by a monomial, you take the monomial and put it into each term. And if you have to, fellas, if you have to, don't be afraid to write each little individual problem out. So if I do that properly, 2xy squared into 8x to the 4th y squared becomes 4x to the 3rd, and y squared over y squared is 1. Does that make sense? What do you do to the exponents when you're dividing? You simply multiply. Now, I'm going to take 2xy squared and put it into 6x to the 3rd y to the 3rd. That's going to give me 3x squared y. Agreed? Agreed?
Yes, sir.
And then finally, let me get this out of here. I'm going to take the last term divided by the GCF, and I'm going to get what?
Y squared.
Negative y squared. Agreed?
Sure.
Yes or no?
Yes, sir.
Now, on an exam, I would want to make sure that I'm right. So I would simply do that distributive, and then I would find out that I did it properly. Does that make sense?
Yes, sir.
All righty. Comprendes?
Comprendo.
All righty. So I'm going to write down two problems, right? I'm just going to write down one and let you do it by yourself, right? So here we go. Ready? 2x squared y minus 6xy squared plus 3xy. All right, so we know that we're using the GCF. So I'm going to give you a couple seconds to do that for yourself. All right, so why don't you do that now? I'm going to pause the recording. All righty, so what do we get for GCF?
XY.
What we get?
2xy.
2xy.
Oh, XY.
Do you think 2, 6, and 3? What's the biggest
Oh,
number that
I'm
goes in?
tweaked. My
Yeah,
bad,
there you
Coach.
go.
It's
So
xy.
now it's just xy. So now we just divide the polynomial by xy, and we end up with our second term. So if I do this little problem right here, what do I end up with?
2x.
Thank you. If I do this little problem right here, what do I end up with?
Minus 6y.
6y.
Thank you. And then if I do this little problem, what do I end up with?
Plus 3.
3, right? Good. So once you have that done, you could check yourself by doing the distributive property. And if you do that, you should end up with what you started with. Comprende? All righty. So that's the first method that we learned. And then the second method that you learned in 9th grade or whenever you took this was the difference of two squares. All righty. So obviously, if it's the difference of two squares, it has to be a binomial. If it's not a binomial, don't waste any time thinking it's the difference of two squares. And in between, there has to be a minus sign, the difference of. And the two terms must be perfect squares. So if you have coefficients bigger than 1, they just have to be perfect. So for example, 2 is not perfect. 4 is, and 9 is, and 16 is, and 25 is. Like those are examples of perfect squares. So when we have the difference of two squares, we're talking about something that looks like this. A squared, A squared minus B squared. Anytime that you have a binomial that is that, the difference of two perfect squares. When is an exponent perfect? When's an exponent perfect? Hello?
That's 2.
When it's even. So if I tell you x to the 10th, what's the square root of that? X to the 5th. X to the 5th times x to the 5th is x to the 10th. X to the 100th, what's the square root of that? X to the 50th, right? An exponent is perfect when it's even. If it's odd, it isn't perfect. Is that understood? Yes or no? Now, we know that when we have the difference of two squares, we're going to have two binomials. And the first term of each is the square root of the first term. And the second term of each is the square root of the second term. One gets a plus, one gets a minus. Done. All righty? Does that make sense? So we can do this really easily. We give you something that looks like this. 4x squared minus 25. You're asked to factor that. So you see two terms, but before you jump to GCF, you sit there and go, ooh, two terms with a minus sign between them. I wonder if these two terms are perfect. Well, we know 25 is. What's the square root of 25? 5. And we look at x squared. We know x squared is perfect. I wonder if the coefficient's perfect. Is 4 perfect?
Yeah.
Of course it is. So I know I'm going to get 4x here. Oh, my bad. I know I'm going to get what? I'm going to get 2x and 2x. And we get 5 and 5. And one's plus and one's minus. Done. That's not a big deal, right? Right? Not a big deal, right? Let's try one more. 49 minus 4x squared. I wonder if that's the difference of two squares. Well, it will be. It's the difference for sure. And it is the difference of two squares if 49 is perfect and 4x squared is perfect. Well, we know 4x squared is perfect. We just did it. What's the square root of 49?
7.
What's the square root of 4x squared?
2.
2x. And then one's plus and one's minus. Not a big deal, right? All right, now, sometimes they write it in such a way where they just try to confuse you. So, for example, all righty. Now, if you look at this problem, initially it doesn't look like a binomial, but it is a binomial because this is one term. And I have the difference of two squares. It's just that one of them isn't just a single number. It's a binomial itself. So this is going to look like this. X plus y, x plus y. One's plus, one's minus, z and z. There you go. Make sense? Does everybody see how that's the difference of two squares?
Yep.
Does everybody see how that's the difference of two squares?
Yep.
All righty. Moving on. Now, quadratic trinomials. What's quadratic mean? Somebody tell me what quadratic means.
Like 4.
No. Who said 4? Who was that?
Mm.
Who was that?
It was me, sir.
Who's me?
Arthur.
Arthur. Eventually, you'll all go to college someday. And there will be something on your campus that will look like this. And you'll have 4 buildings. And they'll be organized in such a way that everybody on campus will call it, hey, let's meet at the quad. What's the quad?
The second power.
Square.
It's a square. Oh, quadratic trinomials. Trinomial.
The second.
Three terms with a degree of 2. So we always talk about this. All right, ax squared plus bx plus c. All right, so we have to learn how to actually factor that. Now, you'll notice when we factored using the GCF, we got a monomial times a polynomial because the GCF is one term. When we did the difference of two squares, we got a binomial times a binomial. Well, when we do this, we're going to get a binomial times a binomial as well. All right? All right? So what we need to know is the first term of each is simply the root of that. The second term of each is the factors of the constant that add up to the coefficient of the linear term. Remember, right? This is the quadratic term, this is the linear term, and this is the constant. So let's go through a couple of problems. All right, so we're going to do we're going to do two different types. All right, so the first ones are really easy. All right, x squared plus 7x plus 12. Right, and I ask you to actually, all right, factor that. So you know it's not the difference of two squares because it has three terms. And you look at it really quickly and you'll notice there is no GCF other than one. I have what we call a quadratic trinomial. So I know that when I factor it, I'm going to get two binomials. The first term of each is simply the square root of that. So what's the square root of x squared? X and x. Now, the second term of each, including its sign, is simply the factors of the constant that add up to 7. Factors of a positive 12 that add up to positive 7. Well, hopefully we know that it's 4 and 3. But sometimes you might actually have to write this out. So you might have to go like this. 12 and 1, negative 12, negative 1. 6 and 2, negative 6, negative 2. 4 and 3, negative 4, negative 3. Now, how come we chose this as our answer? Because that's the only pair where the sum is the linear coefficient, right? This would be 13, negative 13, 8, negative 8, negative 7. All right, so that's not really that big a deal, right? That's really not that big a deal. Does that make sense, fellas? You remember that, right? Hello?
Yes, sir.
Hello. All righty. So I give you something that looks like this, ready? All right, so x squared minus 6x plus 9. Now that's a perfect square. So we're going to go, oh, bingo, right? We're going to go, what's the first term of each? X, right? Now, give me the factors of a positive 9 that add up to negative 6.
Negative 3 and negative 3.
Yeah, negative 3, negative. That's called a perfect square trinomial. We'll get into that a little bit later. All right, we'll get into that a little bit later. All right. Now, those are really easy. And the reason they're really easy is because A is 1. What did we say A was? The coefficient of the quadratic, all right? The coefficient of the quadratic. It gets a little bit hairier when A is greater than 1, all right? It gets a little bit hairier. And the reason it gets hairier, fellas, is because there's more possible answers. So I'm going to teach you a little trick to help you do this. Ready? So we got 2x squared minus 5x minus 7. All right? And you're asked to factor that. And fellas, when you're asked to factor it, you know you're going to get two binomials. Why? Because it's a quadratic trinomial. A quadratic term, a linear term, and a constant term. So it's a degree of 2, 1, 0. That is a quadratic trinomial. Now, unlike the other ones we just did, A is a number other than 1. Now, this one ain't too bad because it's 2. So there's only really one way to get 2x squared. What is it? It's 2x times x. That's the only way you're going to get 2x squared, all right? But if it was something like 8x squared, well, now you could have 8x times x, and 4x times 2x. What if you had 12x squared? You do 12x times x, 6x times 2x, 4x times 3x. Now all of a sudden, there's a lot more possible answers. There's a lot more numbers. There's a lot more numbers that can go here and here. So this one's kind of easy, but I'm going to show you a little trick. I'm going to show you a little trick that Brother Thomas taught us in 7th grade. Ready? When you have this, and you don't have to use this if you don't want, right? When you have a quadratic trinomial that has a coefficient of the quadratic term bigger than 1, draw yourself a little box. And then break your box into 4 boxes. And in the top left corner, put the quadratic term. And then in the bottom right corner, put the constant term. All right? Comprende? Everybody got that?
Yes, sir.
All righty. Now, the other 2 terms, the other 2 boxes, right? Right? The other 2 boxes is really easy. Ready? All you got to do is take 2 and negative. What's 2 times negative 7?
Negative 14.
Yep. Negative 14. Give me the factors of negative 14 that add up to negative 5.
Bro.
2 and 7.
Say that again?
Negative 7 and 2.
Yeah, negative 7 and positive 2. And then all you gotta do is put an X at the end of them. And then you can put 1 in here and 1 up here. And guess what it matters? Guess what? It doesn't matter which one you put where. All righty? So far, so good? We're all following?
Yes, sir.
Now all you gotta do is go over, all right? So you're gonna go like this. Look at the 2 top boxes. Ready? See these 2 top boxes? What's the GCF?
2x.
2x.
Yep. Look at the 2 bottom boxes. What's the GCF?
Negative 7.
Well, it's going to be 7, right? And we're going to put a negative in front of it because the box right here next to the number is negative. There you go. 2x minus 7. Now, let's go up. What's the GCF?
X.
X. Let's go up again. What's the GCF?
1.
1. How come it's going to be positive? Because this is positive. This is negative because this is negative, right? So we got what? X plus 1. All righty. Now, if we did that right, what should we get? What's 2x times x?
2x squared.
What's 2x times 1? 2x minus 7x minus 7. What's this?
Minus 5x.
Beautiful. All righty. Now, the box just makes things a little easier. Let's do another one with the box. I love the box. I learned the box in 1977. Wow. So, how do I know I'm going to use the box here just to make life easy for myself? Because I got a quadratic trinomial with a lead coefficient bigger than 1, right?
Hey,
So let's
Coach, that
go
had to
up.
be a long time ago, wasn't it?
Huh?
That was a long time ago, wasn't it?
1977, Chief. All righty. What goes here? 5x squared, right? What goes here? What goes right here?
Negative.
Negative 6. All right, good. So all you got to remember is that the quadratic term goes in the top left and the constant term goes in the bottom right. Now, multiply 5 and negative 6. Give me 5 times negative 6. Negative 30, right? Hello?
Yes, sir.
All right. Give me the factors of a negative 30 that add up to -7.
And 3. No,
Huh?
-10 and 3.
-10 and +3, and then just stick an X after each of them. And remember, fellas, it doesn't matter which one goes. You can do it either way, right? And now you just find GCFs, right? We're going to go across. What's the GCF?
5x.
Now, GCF. Across the bottom. 3. And how come it's going to be positive?
Because
This is positive. So we got 5x plus 3. Now, let's go up. GCF.
X.
Yep. And then we're going to go up the next column. Go.
-2.
It's going to be -2. Yes, it's 2, right? So this is 2, and it gets a negative because that's a negative, right? And then you can go like this. Check yourself. 5x squared minus 10x plus 3x minus 6. Combine your like terms. Alrighty. So I've always used the box. I hope you can use the box. It might make life easier for yourself. Otherwise, you might have a lot of time trying to figure out which of the possible answers is right. All right? Does that make sense? So that gives us the GCF, the difference of two squares, and the quadratic trinomial. The last thing we said we were going to go over was this thing called factor completely. All right, now, what that simply means is that once you factor something, you make sure that what you factored can't be factored, right? So you make sure your factors can't be factored. So when we went like this, ready, watch. X squared plus 7x plus 12. I got x plus 4 times x plus 3. So when I look at the two factors, neither one of them can be factored. So that is factored completely. Sometimes when we factor, though, we get a factor that can also be factored. So anytime you see directions that say, for each of the following, factor completely, that should be a hint to you that after you factor it, you're going to factor one of the factors. So let me show you what I mean. Nice, easy one. Ready? 2x to the 4th minus 8x squared, right? Now, we know that the first thing we should do is look at all our terms and see if there's a GCF. Look at those two terms. You guys see a GCF?
Sir.
Yeah, what do you think? 2x squared? Hello?
I think so.
So if I divide both terms by 2x squared, what do I come up with? Well, over here, what do I end up with? What's 4 minus 2?
X squared.
Thank you. And what do I come up with over here? Well,
minus 4.
negative by minus 4. All righty. Now, if on your quiz, you leave that as your answer when it says factor completely. Now, you have factored it, but you haven't factored it completely. Well, this one's fine. This factor here is fine. But what is this? What's x squared minus 4?
4x minus 4.
Is that the difference of two squares?
Or x plus 2, x minus 2.
Yep. So when you have a polynomial and you factor it, you then have to make sure that the factors you have can't be factored themselves. All right? If they can be factored, right? If something can be factored, you just Factor that, but don't forget this. So here is this complete. Does that make sense? All right, let's give you another one. This is going to give you a little more steps, right? X to the 5th, y squared, minus xy to the 6th. All right. Well, I simply look at that and I go, ooh, that's a GCFer, right? What's the GCF between those two terms? Yes or no?
Yes.
I look at the x. I got x to the 5th and x to the 1st. What's the smaller number? X to the 1st. I got y squared and I got y to the 6th. What's the smaller number? Y squared. All righty. So now I just have to divide both terms by that, right? So what do I end up over here with? Well, that cancels. What's 5 minus 1?
4.
Thank you. And then this cancels. What's 6 minus 2?
4.
Ooh. Now, you have factored the polynomial, but you haven't factored it completely. Somebody tell me why.
Well, the difference of 2 squared.
This is the difference of 2 squares as well. So this doesn't disappear, fellas. X, y squared. Now I'm going to get two binomials. Ready? Give me, what's the square root of x to the 4th? What's the square root of y to the 4th?
Y squared.
And one's plus and one's minus. Now, if you're finished, you're wrong. Why? Look at that last term. What's that?
Difference of 2 squares.
2 squared.
Yep. So I still got these two terms. And this term right here is the difference of 2 squares. So what should I get? X plus y times x minus y. All righty? So you got to be super careful. Now, fellas, anytime I would see directions that say factor completely, I would be on guard. All right? Does that make sense? Let's do one more, right? So 2x to the 3rd plus 8x squared plus 8x. Now, fellas, we know that that's not a quadratic trinomial because it's not quadratic. It is a trinomial, but it ain't quadratic because it has a degree of 3. So I immediately sit there and go, oh, that's gotta be GCF. Look at those 3 terms. What goes into everything?
2x.
Yeah, 2x. Then if I divide each term by 2x, what do I get? What's this become? X squared, right?
Squared plus
What's
4.
this become?
4x.
And what does this become?
4.
Now, am I finished?
No.
No, why not?
Still got to factor in some.
Because I can factor out this quadratic trinomial. What's the first term of each?
X.
Give me the factors of 4 that add up to 4.
2.
All righty. Does that make sense? Hello. All righty. So there's a brief review of factoring. Somebody tell me why it's so important to know how to factor.
You in PreCalc, you in calculus.
All righty. Let's take one of the problems we did earlier. X squared, right? Let's go x squared plus 7x plus 12. Well, that's just a polynomial. So guess what I can do with that? I can factor it, right? But what happens when I go like this? What did I just take my polynomial and make it? What do you call anything that has an equal sign in it?
Equation.
Yeah, this is what we call a quadratic equation. This one here specifically is a quadratic equation. It's a type of polynomial equation. So what we want to do when we have polynomial equations is we want to actually set them equal to 0. We want to set them equal to 0. Then we want to factor the polynomial and then let each factor equal 0. That's all. So let's see what that looks like. All right. So we got x squared equals 4x plus 21. All righty. Well, I know this is quadratic, and I know it's an equation and not a polynomial because I see an equal sign. So what we want to do is we want to put it in standard form, which simply means quadratic term, linear term, constant term equals 0. So the first thing I'm going to do is move these two terms over. And I do that by adding the opposite. So there's the first thing I've done. Now all I got to do is factor the polynomial. So this is a quadratic trinomial. Well, the first term's easy. Now, give me the factors of a negative 21 that add up to negative 7. Negative 4.
Negative 7 plus 3.
All righty. Now, if I look at what I've just done, I've told you this number, x minus 7, times this number, x plus 3, equals 0. If you multiply two numbers together and get 0, what do you know? One of those numbers is equal to 0. So you got to find out what number or numbers would make either one 0. So what you do is you simply take each factor and let each factor equal 0. So over here I get x is 7, and I get x over here is x is negative 3. So what you know is that whenever x is either 7 or negative 3, that equation will work. And there's your solution. Does that make sense? All right, so that's what we're going to start tomorrow, because I think we've used a lot of time, huh? Head. All righty. So anybody have any questions right now? So make sure on Wednesday we start with solving quadratic equations. Does that make sense? Yes or no?
Yes, sir.
Anybody have any questions?
No,
All right,
sir.
some of you guys owe me work. Get it to me. Comprendes?
Yes, sir.
Comprendes.
I'm going to put up a worksheet for you, and that will be due Wednesday night at 11:59. Is that understood?
Yes, sir.
Yes, sir.
All righty, good. If anybody has any questions, you can stay on and ask me. Otherwise, have a good day.
All right,
Thank you, Coach.
All righty.
Hey, coach.
Hold on.